Hello, let me just quickly talk about logarithmic graphs. Now, as you know, logarithmic graphs, they pass through 1, 0 for a normal logarithmic graph of log e of x. Now, I want to talk about what happens when it is dilated by a factor of 1 over n, which basically means there's a coefficient in front of the x here, so there's an n, that's the coefficient. N can be anything, literally any real number, right? And it says, this is the normal, so this is the normal equation, and this is the dilated by a factor of 1 over n from y-axis or parallel to x-axis. Now, what we're going to do is we're going to see a pattern. So, this is for you, my future self, and if anyone else is watching this, possibly. So, find x if y is equal to 0. So we have to do x, and we know y is 0. So that's our coordinate. Right now, I'm going to find for y equals log e to x. So, goes into y equals log e to x. So, really simple. We just plug in y is equal to 0. Of course, is y equals 0 equals log e to x. And the only thing that makes it turn into 0 is if x is something that will turn this 2 into a 1, because natural log of 1 is 0. So, the only thing that does that is when x equals 1 over 2. And that is the answer. Yeah, so it's pretty simple. So, let's put it on here. So, a normal logarithmic graph looks like this, right? And now we have to plot this thing. So, our new coordinate is, we know that when y is 0, that x is 1 over 2. We put that in, so it's like half here or somewhere. Let's draw a new line. Right, cool. So we already solved that question, pretty simple. So this is what happens. Just from looking at this, it seems that whenever there's a coefficient in front of the x, right here, it changes the starting position. It changes the whole entire graph itself in the function, but an easily noticeable pattern is that it changes where it passes through the x-intercept, or the x-axis, sorry, not x-intercept. So we see that when it's 2, it actually halves the point at which it passes through the x-axis. So this is now at 0.5 instead of 1, so it literally halves it. So let's see if we can find a pattern. So, if it's 5x, you think it's going to pass through 0.2, because guess what? If y equals log e to x divides the 1 by 2, and that turns into 0.5, which is a half, 1 over 2. Then if we have a 5, wouldn't that make it into a 1 over 5, which is 0.2? So let's see that. We're going to assume that this will pass through 0.2. That's the coordinate we want to see if it will work. So let's see. When we substitute y equals log e 5x, and we say y is equal to 0, find x, we can say 0 equals log e 5x. So we need to find something of x, which will turn this whole thing here, into 1. And well, guess what? It's an easy thing. When 5 over 1 is multiplied with 1 over 5, becomes 5 over 5, which is equal to 1. And guess what? 1 over 5 is 0.2. Therefore, when y is equal to 0, x is equal to 0.2. So, it's just simple like multiplication if you think about it right now. But basically, this graph of y equals log e 5x will pass through the x-axis at 0.2. So now we can identify that the dilation factor of 1 over n, which is the coefficient of x in front of x, from the y-axis or parallel to the x-axis, will in fact manipulate and change its position at which it passes through the x-axis. Now, I'm not a teacher, so I don't know if this is like full on true, like, yeah, but I mean, this is what I'm seeing, so trust you how you want to believe. Ask questions to your teacher if you want to get more confirmation. Thank you, and have a great day, future myself, and maybe other people.